Good morning students, this is Latif sir. In this video I am going to start the chapter 4 of class 11th chemistry. The topic is chemical bonding. In class 10 you have already studied to some extent about different types of chemical bonding. In class 11 again you have to read in details, and many new topics are also included in class 11. Okay, so first you have to know what is a chemical bond. You know, in nature almost 118 elements are found, and out of these 118 elements, except noble gases or inert gases, all the other elements are reactive in nature to some extent. Okay, some elements are highly reactive, some elements are moderately reactive. Okay, that is, they are unstable, and for their stability they form chemical bonds among themselves. So first you have to know what is a chemical bond. It is a force of attraction that holds different atoms in a molecule. Now see, octet rule. Octet rule. What is octet rule? You know that, you have already studied. Octet rule means 8 electrons in the valence shell of an atom. You know, noble gases or inert gases, they have 8 electrons in their valence shell. That's why they are stable in nature, except helium. Helium has only 2 electrons in the valence shell of helium, only 2 electrons. So it is duplet rule for helium. Noble gases, that is except helium, that is neon, argon, krypton, all the noble gases has 8 electrons in its valence shell, and that is why noble gases are reactive, are very stable. And all the other elements, they want to attain the noble gas electronic configuration, that is 8 electron in its outermost shell, and this is known as octet rule. Okay, so atoms of different element take part in chemical combination in order to complete their octet or to attain the noble gas configuration. This is the reason why elements form chemical bond, to attain noble gas electronic configuration or octet, to attain the octet, that is 8 electron in their outermost shell. And the outermost shell is known as valence shell, and the electron present in the outermost shell is known as valence electron of that atom. And this valence electron of an element, of an atom, this valence electron of an atom take part in chemical bond formation. That is, valence electron takes part in chemical combination. Okay, so why atoms forms chemical bond, or they takes part in chemical combination? This is because they want to attain noble gas electronic configuration, to attain stable electronic configuration. Okay, so now see the modes of chemical combination or types of chemical bond. Modes of chemical combination, there are mainly three modes of chemical combination. One is electrovalent bond or ionic bond. Second one is covalent bond, and third one is coordinate bond. There are three modes of chemical combination. So first mode is electrovalent bond or ionic bond, and it is formed by transfer of electron from one atom to another atom. Okay, so first, by transfer of electron, it is electrovalent bond or ionic bond. The chemical bond which formed by complete transfer of one or more electron from one atom to another atom is called electrovalent bond or ionic bond. The chemical bond which is formed by transfer of one or more electron from one atom to another atom is called electrovalent or ionic bond. So ionic bond is formed by transfer of one or more electron. Second mode of chemical combination is by sharing of electron, which is covalent bond. Okay, that is, the elements can attain their attain the octet electronic configuration by sharing of electrons, by sharing of their valence shell electron. Okay, so the bond which is formed by equal sharing of electrons between one or two atoms is called electrovalent bond. Okay, so electrovalent bond is formed by sharing of one or more electron, and in electrovalent bond the electrons are contributed by both the combining atoms. And the third type of bond is coordinate bond or dative bond. We have already studied about this three type of chemical bonds in class 10. Okay, so coordinate bond. What is coordinate bond? When the electrons are contributed by one atom and shared by both the atom, then the bond formed is known as dative bond or coordinate bond. In dative bond or coordinate bond, electron pairs, at least one electron pair is shared by one atom and will be equally used by both the atom. Okay, so when the electrons or electron pair, lone pair of electron are contributed by one atom and shared by both, the bond formed is known as dative bond or coordinate bond. Okay, so three types of bond: ionic bond, covalent bond, and coordinate bond. Okay, now see, first type of chemical bond, ionic bond. I have told ionic bond is formed by transfer of one or more valence electron from an atom to another atom. And ionic bonds are generally formed by metal and non-metal, between metal and non-metal. Okay, so ionic bond, also called electrovalent bond, is formed by complete transfer of electron from one atom to another, and it is formed between a metal and non-metal. Generally metals of group 1 and 2, they forms uh, electrovalent bond or ionic bond with non-metals of group 15, 16, 17. Okay, so ionic bond, it is formed between metal and non-metals. Metal generally loses one or more electron or transfer one or more electron to the non-metal, and therefore metal is converted into positively charged cation, and non-metal is converted into negatively charged anion by gaining electron. And after the formation of cation and anion in ionic bond, due to presence of very strong electrostatic force of attraction between the cation and anion, they combine together to give ionic or electrovalent compounds. Okay, so in ionic bond formation, first cation and anion are formed. Cation, the metal can lose one or more electron to give the cation, metal cation, and the non-metal accept one or more electron to give the anion. And after formation cation anion, they combine due to presence of strong electrostatic force of attraction between the opposite charge. For example, see NaCl formation. NaCl is a electrovalent compound or ionic compound. In NaCl, sodium metal is present and chlorine non-metal is present. Okay, so sodium has one electron in its outermost shell and chlorine has 7 electrons in its outermost shell. To attain the noble gas electronic configuration, sodium transfer its one electron from its valence shell to the valence shell of chlorine, and therefore both sodium and chlorine become octet. So sodium becomes Na plus after losing one electron, and chlorine becomes Cl minus after gaining an electron. Okay, and sodium plus attained the electronic configuration of neon, and chlorine Cl minus is electronic configuration of argon 288. And after formation of cation and anion, they combine. Due to presence of strong electrostatic force of attraction between Na plus and Cl minus, they join together to give NaCl, sodium chloride. Okay. And in this compound I have told, so Na plus has electronic configuration of noble gas neon and Cl minus represent the electronic configuration of argon. One more example is given, formation of magnesium oxide. Magnesium oxide. In this compound, electronic configuration, you have to know what is the electronic configuration of magnesium. Magnesium atomic number 12, so its electronic configuration is 282. So magnesium has 2 extra electron in its valence shell, and oxygen has 2 less electron. Okay, oxygen atomic number is 8, so in first cell 2 electron, in second cell 6 electron. Okay, so to attain noble gas or octet electronic configuration, magnesium transfer its 2 valence shell electron to oxygen atom, and therefore magnesium is converted into magnesium 2 plus and oxygen is converted into O2 minus by gaining 2 electron. And now see, both Mg2 plus and O2 minus ion has noble gas electronic configuration neon, electronic configuration of neon. Okay, and after formation of Mg2 plus ion and O2 minus ion, they join together to give MgO. Now see, what is electrovalency? Electrovalency is the number of electron lost or gained during the formation of ionic or electrovalent bond. Electrovalency is the number of electron lost or gained during the formation of ionic bond. For example, during formation of magnesium oxide, magnesium loses its 2 electron, so its electrovalency is 2. Similarly, oxygen gains 2 electron, so its electrovalency of oxygen is also 2. In FeCl3, electrovalency of Fe is 3, and in FeCl2, electrovalency of Fe is 2. Okay. Now see, factor affecting formation of ionic bond. There are some factors which can affect the formation of ionic bond. First one is ionization enthalpy. You know, ionic bond is formed between metal and non-metal, and metal should have very low ionization enthalpy. And what is ionization enthalpy? The energy required to remove an electron from the outermost shell of an gaseous isolated atom to convert it into cation. Okay, so lesser the ionization enthalpy, easier will be the formation of cation. Lesser the ionization enthalpy of the metal, easier will be the formation of cation and have greater chance to form ionic bond. Okay, as the ionization enthalpy of alkaline earth metal is very low, that's why they have more tendency to form ionic bond. Okay, so ionization enthalpy, so we can conclude that lower the ionization enthalpy, greater is the chance to form ionic bond. That's why alkaline earth metal, due to low ionization enthalpy, they can form ionic bond easily with non-metals. Now second condition is electron gain enthalpy of non-metal, electron affinity or electron gain enthalpy. Okay, so electron gain enthalpy, it is defined as the energy released when an isolated gaseous atom takes up an electron to form an ion. Electron gain enthalpy or electron affinity, it is the energy released when an isolated gaseous atom takes up an electron to form an ion. So greater the negative electron gain enthalpy, easier will be the formation of anion. As a result, probability of formation of ionic bond increases. Okay, so non-metal should have very high value of negative electron gain enthalpy. Okay. Next condition is lattice energy. You know, the ionic compounds are generally solid in nature. They exist as crystal lattice. Okay, crystal lattice, that is three-dimensional arrangement of ionic compound is known as, in solid state, three-dimensional arrangement of constituent particles cation and anion in solid is known as crystal lattice. Okay, and every ionic solids have some lattice energy. Okay, what is lattice energy? It is defined as the amount of energy required to separate 1 mole of ionic compound into separate oppositely charged ion. Okay, for example, NaCl. In NaCl crystal lattice, there are many Na plus and Cl minus ion, and energy required to separate Na plus and Cl minus ion from its 1 mole NaCl crystal is known as crystal lattice energy of NaCl. Okay, and ionic compounds have very high value of lattice energy due to presence of strong electrostatic force of attraction between the opposite charge. And this lattice energy of ionic compounds depends on two factors: size of the ions, cation and anion, and charge on the ions. Higher the value of first one is size of ions. Okay, in ionic compound, smaller the size of ions, cation and anions, greater will be the lattice energy, because smaller the size, greater will be the electrostatic force of attraction, and greater will be the lattice energy. And that is this is because more energy will be required to separate cation and anion from the crystal lattice. And second factor is charge on the ion. Greater the magnitude of charge, greater is the interionic attraction between cation and anions in ionic compound, and hence higher will be the lattice energy. That is why lattice energy of NaCl is less than lattice energy of CaO, because in NaCl Na plus and Cl minus charge is plus 1 and minus 1. In CaO, calcium oxide, charges are plus 2 and minus 2. So greater force of attraction in calcium oxide than NaCl. So lattice energy of calcium oxide will be higher than lattice energy of NaCl. Okay, now see characteristic of ionic compounds. We have already studied these points, these characteristics, you know that. So first one is physical state of ionic compound. They are generally characteristic of ionic compound, they are generally solid in nature. Okay, they are generally solid in nature. And ionic compounds exist in solid state. They exist uh, as oppositely charged ions, and there are very strong electrostatic force of attraction between the opposite charges. Okay, and in ionic crystal in solid state, each cation is spherically, each cation for each cation there are large number of anions, and for each anion there are large number of cations. Okay, that is in ionic compounds in solid state. Ionic compounds, molecules of ionic compounds do not exist as a single molecule. Okay, that's why for ionic compounds, instead of molecular weight, formula weight term is used. And next characteristic is melting point and boiling point. Melting point, and as the ionic compounds are solid in nature, their melting point and boiling point is very high. Solubility, they are soluble in polar solvent like water. Okay, they soluble in water. And electrical conductivity, due to presence of oppositely charged ions, that is cations and anions, they can conduct electricity in molten state or in aqueous solution, but not in solid state, because in solid state the ions are not free. Ions are very tightly held together. Okay, and their ionic reaction, their rate of reaction is also high. And now see covalent bonds. What is covalent bond? You know, covalent bond is formed by sharing of one or more electron between two atoms. Okay, so if the combining atoms are same, the covalent molecules is known as homoatomic covalent molecule, like H2, like Cl2, like O2. These are homoatomic covalent compounds. And if the covalent bond or covalent molecule formed by sharing of electron, if the atoms in covalent molecule are different, then the covalent molecule will be the covalent molecule is known as heteroatomic molecule. Okay, covalent molecule formed by combination of same type of atom is known as homoatomic, and covalent molecule formed by combination of different type of atoms, and then it is known as heteroatomic, like HCl. It is formed by combination of H and chlorine, hydrogen and chlorine. Okay, water is heteroatomic, ammonia is heteroatomic molecule. Okay, now see Lewis dot structure of covalent bond formation. Formation of hydrogen molecule, H2 molecule. Here duplet rule is valid or applicable. For hydrogen, hydrogen do not follow the octet rule, H2 molecule. It follows duplet rule, 2 electrons in its valence shell, that is electronic configuration of helium. Formation of O2. In O2 molecule, there is a double bond, double covalent bond between two oxygen atoms. That is, two electron pairs are there are two electron pair between two oxygen atom. Okay, and both the oxygen atom attain the noble gas neon electronic configuration. Formation of water, electron dot structure of water is given. There is two oxygen, there is a single covalent bond between each hydrogen oxygen bond in water. Okay, all this Lewis dot structure you have already studied in class 10. Lewis dot structure of electron dot structure of ammonia also given here. Single covalent bond present in ammonia. Each nitrogen hydrogen bond is single covalent bond. Here also some Lewis dot structure of some other compounds or covalent compounds also given. You can see Lewis dot structure of carbon monoxide, CO. In CO, 3 electrons pair are formed between two carbon and oxygen atom. So there is a triple covalent bond between oxygen and carbon atom in carbon monoxide. In carbon dioxide, double covalent bond, two double covalent bonds are there between each oxygen and carbon. So in CO2, there is single covalent there is double covalent bond between oxygen and carbon in carbon dioxide. In oxygen molecule, double covalent bond, that is, two electron pair is formed between two oxygen atom. O3 molecule, ozone, you can see structure of ozone. There is one double covalent bond and one single covalent bond. Okay, so you have to practice all this structure to given. You have to practice all this Lewis dot structure in your copy. Okay, structure of SO3, structure of HClO4, structure of Lewis dot structure of NO2, Lewis dot structure of SO4 2 minus, all these are given here. So this you have to practice all this Lewis dot structure. Okay, and today whatever I have told, this is basic introductory part of this chapter. Okay, and mainly you have to read this part thoroughly. No question will ask from this part, because many more new topics, important topics are there. From this topic question will be asked. Okay, so yeah, but you have to know this concept: formation of ionic bond, formation of covalent bond, formation of coordinate bond. This concept Lewis dot structure, so you have to it is must, you have to know. Okay, Lewis dot structure of covalent bond, of ionic bond. Okay, so next day again I'll discuss. Thank you, students.